Hey everyone, it's Shane, Solution Architect at Red Hat. I'm joined here today with Simon. What we're going to look at today is, I guess, some practices and processes around how to better manage base images inside the organization. So these are typically images you might use to start a build process or start an application deployment. And there's a lot of interest at the moment in better managing these base images and how we lifecycle them and build provenance around it. So I might ask Simon just to kick off with, I guess, what we're starting to see from some of these customers.
Yes, thanks a lot, Shane. Thanks a lot for taking the time, and it's great to be doing this video with you. I'm really excited, actually. Congratulations on the beautiful Red Hat logo as well, and I'll wear something better next time. So effectively, thanks for that. I've had, over the last few months, several requests from customers in terms of a couple of things. One, the updates, the impact of the change of security format for CSAF and VEX to the report of CVEs, RSAs, and so forth. How does that impact their management from a security SecOps perspective? And the other one, in terms of the use of the UBI and how can they harden this UBI, make them production ready for the specific environments effectively, right? That's the context for it. Essentially, in the financial sector, effectively, lots of our banks are using UBI as the base Linux distribution for the building of the Linux containerized application effectively. So maybe from your perspective, Shane, I mean, what do you see with our customers? What sort of like technology, like new things happening do you see from an APAC and ANZ perspective?
I'm certainly starting to see more focus in supply chain security. So customers wanting to use new tool sets like Sigstore to provide provenance around builds, being able to start to bring that into some of these platform engineering processes. So the idea that I can create a golden thread from development into production and start to bring some of these hardening processes and bringing security into that workflow as well. So being able to better analyze and manage some of those base images that are getting pulled into builds and supporting that through something like Developer Hub and those platform engineering processes to provide services to developers. I think there's also an aspect here of I guess how we can start to use some of those tools and technologies available. So something we often see from customers is they go to the Red Hat Container Health Index, the catalog. They can see there's no unapplied critical or important updates, but they still want more information on what's actually inside this container image. They can see the packages, but they want to know more about vulnerabilities. They maybe want to package their own PKI inside the universal base image. Essentially, they want to make some changes to this to support it as part of their platform engineering processes. So one of the, I guess, the really important changes we made recently is being able to validate the provenance for those universal base images using Sigstore and cosign. So what I wanted to do quickly is just take a look at that change and how I can start to bring that into these hardening processes. Awesome. So the first thing I'm going to do is just take a look at the Red Hat UBI. So in this case, hosted at registry.redhat.io. I'm going to do a crane listing across that. And what I can see is now inside that container registry, we're storing those attestations and signatures for the Red Hat Universal Base Image. So this is created with cosign. It means that we're now signing those images using cosign, and we can better support teams to bring that provenance into their build pipelines and their platform engineering processes. So the way I can do that is using the Red Hat release keys. So container images, universal base images signed using the Red Hat product signing keys. I'm just going to grab this key, Red Hat release key 3, and we'll store that inside this file, redhat.pub. And now what I can do is verify that universal base image using cosign.
Impeccable Linux skills so far, Shane, I have to admit. It's pretty impressive. The CLI typing, very good.
Awesome. So yeah, we can verify that. Now here I'm doing a cosign verification using that Red Hat release key. I'm just going to get the latest digest of that from the Red Hat registry. And what I should see is that we can validate those cosign claims, we can validate those signatures, and essentially verify that this universal base image was created by Red Hat and verify that using that cosign key. So we can do this much more simply now than we could with detached signatures, and support teams to bring that into that supply chain security model and those platform engineering processes.
So effectively, what you're describing here would be typically the first step of the build or the pipeline. Effectively, just checking, hey, I've got this UBI. Is it a legit provenance? Is it a legit piece of software signed by a legit vendor? Effectively.
Absolutely, and I think that's what we've started to look at, is building that pipeline. Now you're much more familiar with this than I am. I guess, would you be able to take us through this process to better manage those universal base images and create some of those golden images we can use inside platform engineering processes?
Yeah, so effectively, as part of like I mentioned initially, some of the requests from customers is, can you take us through what would be the steps, the relevant steps for us to work from the UBI effectively? So one of the first steps we do is exactly what you did, Shane, is effectively pull the latest Red Hat UBI and check that this UBI has been signed properly by a proper by Red Hat effectively in that context. The next step from that is we pulling this image, building it, and putting it into a local repo. Because one of the points you mentioned before is, yes, there's a lot of information on the Red Hat website. However, customers may want to see more than just A or B or C rating. They may want to see a set of associated packages and all the vulnerabilities associated with those packages. And that also links back to this VEX discussion, this change of format from the security reporting, where we can see the criticality of some of the CVEs for different type of packages effectively. So we typically pull the image, build it, upload it into a repo, check it's been signed properly. And based on that, you can do the analysis of the image. And we'll see that even in UBI, there are some vulnerabilities. They're not critical, like you mentioned, but there's still some packages maybe that could be done with being removed. For example, one of the big suspects is the vim minimal package in that regard. So that's the next step of the pipeline, is we start to harden the image, for example, removing just this package, and then we can start generating an SBOM associated with that, upload the SBOM to whatever container registry the customer is going to be using. In our case, we're going to be using Quay, because Quay displays all these great functions associated with the new VEX format effectively, and you can see the difference of the base UBI versus the hardened UBI, and we upload this image there, and it's ready for consumption after that for all developers to do whatever they need to do with it effectively.
Yeah, and I think that's what you've represented here. So we're building that image, pushing it into the repo, signing it internally, removing those unnecessary packages, and then essentially we can bring that into that platform engineering approach. So where we've got maybe some of those catalog services created to build from this hardened UBI, being able to support that through Developer Hub. If users try and deploy from that upstream UBI where we maybe haven't integrated our own PKI or removed some of those packages, we block it using those ACS signature policies. So verifying this has been signed by our organization, by verified authorities, whereas for that hardened image, essentially also allowing it then to go through and being validated by those ACS policies.
So effectively, we cover both the build time, the deployment time, as well as the runtime component for the UBI function effectively.
Yeah, awesome. So I'm really excited to see this in action, Simon.
It's been easy. It's been really easy. Let me try and present. Let me try and share my screen now for this one.
For sure.
Okay, so I'm on my OpenShift environment. The pipeline tool we're using is Tekton. One of the benefits of using Tekton is Tekton Chains that can provide all these cosign Sigstore functions along the way effectively. But you don't have to use that. You could run your own, like you were showing, Shane, your own CLI set of function or any other tool that does that effectively. But that's one of the benefits of using Tekton and Tekton Chains in that regard. So what I've done is I've got a set of, on my cluster, set of operators being deployed. I'll spare you the deployment and effort associated with that, but it's all in Git. We'll provide the Git view for that. I've got in my Quay, and I'll deploy Quay locally, and in my Quay environment, I'm going to do, we do the pull of the Red Hat UBI, the upload into the local environment. I'm going to use this as the UBI-based customer folder in there, and we'll see the first part of the pipeline that uploads the image here, and then we can see the vulnerabilities associated with this image. And based on that, we'll say, okay, now we're going to harden this image, and I'm going to run a second pipeline that will bring then this image into the UBI harden demo folder. So as you can see currently, those folders are empty, and I'm going to start to run the first pipeline. So if I go back to my OpenShift console, I'm going to go into the pipeline, and I've called them first pipeline demo and second pipeline demo. So for the first pipeline demo, I've defined a set of tasks, or steps. The first one is checking that the Red Hat UBI is signed. The second one is to clone the repo, build, and push the image into the local repo effectively. So I'm just going to, there's a set of, obviously, with Tekton, you have a set of parameters associated with the various tasks around what's the source image, what sort of keys it be using for checking the cosign function of the UBI image, the various Git repo, location of those, etc. And the way you implement it is you create what's called a pipeline run, where you specify those parameters and start running them as part of your environment. So I'm going to simply rerun the previous pipeline with a set of parameters that I've defined. Again, all of that is available in a Git repo that we worked on together, Shane. And I'm just going to rerun this pipeline. And as you can see, I can have a look at the logs. The different steps are being run, and I'm going to see that the UBI is signed, similar to what you demonstrated by the CLI. That's the checking that the signature is legit on the Red Hat side of things. And I'm going to build and push my image into the local repo. Let's let the pipeline finish, and I'll share with you what's happening in the Quay, the local Quay instance, effectively. And you can see you can track all the logs associated with that, right? Effectively, it's a nice way to do it. I'm not as proficient as you, Shane, for the Linux skills on the CLI. I'm pretty GUI oriented, you know, like the old way of doing things, but that's okay. We can drive it like that.
I like that you're doing an update here as well before pushing that into Quay. So we know that all of that security errata has been provided. When it gets into Red Hat Quay, the security team can kind of take a look and look at that from the latest data with all of that errata applied.
Thanks for that. So effectively, if I go back to my repo, which is the UBI-based function, I can see that there's not a little an image has been uploaded, and I can see that this image has a set of vulnerabilities, and that's more detailed than what we could see from effectively the Red Hat web place, effectively. And you can look from a perspective based on severity of the CVEs, right? But more interestingly, in our case, is which packages are the ones that are created the most amount of trouble. And where is it? If I look at the, here you go, Vim minimal is responsible for a high one, plus 109 additional vulnerabilities. So as part of the hardening decision, one of the decisions would be, well, we don't really need Vim for this image. Let's remove it from that. So same thing, let's say you have an analysis that's a simple analysis, we're just going to remove one package, but that would be the next step of the pipeline. And all of that, again, like we're doing step by step, but all of that could be automated. We could include event-driven capability of functions to drive those type of build and remediation functions in there. So I'm going to go back to my pipeline view. I'm going to be doing the second pipeline demo, similar to before. I'm going to clone the local image, build and push this image to the new repo, generate an SBOM, so the software BOM, to the update based on what I've removed or added as part of my build, effectively. And I'm going to sign the image, and we'll be able to show that this signature is valid effectively from that perspective. Again, there's a set of parameters defined. They're all available in the Git repo. I'm just going to spare you that, and we're going to go directly to the run of this second part of the pipeline. I'm just going to rerun what I ran previously. Again, I'm going to follow all those steps, and I can access all the logs associated with those steps. So cloning the resource, and eventually the image will be uploaded with the SBOM and signed in the environment, effectively. There's a bit of silence.
Yes, essentially so really the output here is that we've got that hardened image. We've removed some of those packages that we don't really care about in production anyway. For example, if we've got this mature platform engineering practice, we don't need Vim inside that image, just presenting another attack surface or allowing threat actors to modify configuration potentially. Remove it. Remove the essentially any of those other components, and then sign that and essentially validate that this image has been through our hardening process and is now available for developers to consume.
So if I go back now to my local query repo on the folder that I created, I can see that I have an SBOM that's been uploaded, as well as the latest, the hardened image, and this one has been signed. And what you can see is that now we went from 5 to 4 and lesser vulnerabilities. And if I go into the packages, I will see that there is no Vim package anymore. Vim's been removed from there, and we can see from the overall view of the image that effectively it went from 5 high CVEs to 4 effectively. So that covers, relatively quickly the build and the hardening and the signing functions associated with the image. Do you want to take us a little bit through what you showed us as part of the image around the runtime deployment and some of how you can use the signature of this image now to enable tracking at deployment time and runtime of those container images?
Yeah, absolutely. So what I might go through now is kind of this process. So how, if I've got that upstream UBI or users trying to build from an image that hasn't gone through our hardening pipeline, how do we kind of block that at the ACS level? Or if we don't want to block it, how do we provide some notifications to the security team that this image is present and it hasn't been through our hardening pipelines? So the way I'm going to do that is using container signatures. So you signed that UBI previously. What I've got created inside Red Hat Advanced Cluster Security for Kubernetes is a signature integration using that same public key. So this is the public key we're using as part of that pipeline. Essentially what I'm going to do is validate that containers are signed using this signature. And if they're not, we're going to block it from the platform using the ACS admission controller. So I've created a policy in here, verify container image signatures. Now, what this is going to do is use that same signature integration to validate containers image signatures and use the admission controller to enforce that and essentially block some of those requests to create deployments referencing unsigned container images. So let's take a look. This is my app deploy project. And what I'm going to do is just create a workload using this unsigned container image. Now, this is just an image I created and pushed up into my repo. If I create this on the platform, what's happening at the moment is inline ACS is verifying those container image signatures, looking at whether this deployment's valid, whether it meets those policy criteria. And you can actually see, I'll just zoom in a little bit. You can see that we've failed that verify container image signatures policy. We've been able to block that from the platform, prevent that untrusted, unauthorized code potentially running on the platform because we've been able to verify that container image signature. So the idea then would be that we could provide some guidance to developers to use those templates available inside Developer Hub, where we've got those pre-hardened images available. We've looked at building them into some of those catalog items to help developers get started more quickly. And we can provide all of that process as part of a platform engineering initiative.
So effectively, the platform engineers build those type of function, and then they can be represented as part of the Developer Hub for consumption by the developers, right?
Exactly. And the best part of this is that the security team still gets some alerts about that. So if I take a look at some of those attempted violations inside ACS, I can see that we've raised a notification that there's been an attempt to deploy an unauthorized container image. We can take a look at the namespace where that occurred. We can take a look at the enforcement actions that took place. Essentially, we can look at all of that capability inside that alert and maybe package that up to the seam and allow security teams to use their own tools to be able to verify and maybe perform some more forensics on that incident. Awesome. So I think what we've showcased today, Simon, is how teams can, I guess, better manage base images as part of those platform engineering workflows. So building that workflow to verify container image signatures, get some more insight into packages and CVEs that are maybe present inside those base images, and then pull that through that hardening pipeline. Like you showed, removing Vim minimal. We don't really need Vim inside container images in production. Let's pull it out. Let's generate SBOM and allow security teams to be part of that process. And then let's make that available to teams, but also build some policy around that on how to manage those hardened image builds as part of that process.
Absolutely. I think that was great. Thanks, Ellen, for that, Shane. And I think this type of process also applies for commercial off-the-shelf software, I'd say. So you can have a base repo for the COTS function, not doing any specific in-house development, but follow the same set of steps for tracing where the source of this software, whether it's the right one to deploy in production, using exactly the similar set of patterns effectively. Would you agree with this statement?
I think so. I think that's certainly where we're starting to see this going, is better processes around supply chain security, being able to manage COTS workloads more effectively, for example, and bringing that provenance into platform engineering.
All right.
So I'll say thank you again, Simon. I thought those pipelines were awesome.
Well, thanks so much. And it's always a pleasure working with you. I'm really happy you brought me along on the journey. That was great. Thank you.
For sure. And thanks again, everyone. We'll see you on the next one.
Cheers.